Hello everyone, just a quick update on the GroClock project that I'm busy doing. It's been a little while. So I was having a look around to see how much space and what I need to do about the physical design part of it. I'm not changing the casing at all. Otherwise it's not a GloClock project, it's just a new project. So that's staying the same. But what I was looking at is on the board, how much space do I have on this size board, because I'm going to replicate the size of the board. This board's being thrown out. This ELAN chip is programmed and manufactured. It's programmed during manufacture, and so it's a one-time program. I can't change it. I can't hack it from that point of view. Although, again, if somebody knows how to do that, then let me know. But what it does afford me to do is to play with some other processors that I want to do, and those being the ST processors, which I've been having a bit of a play with. I've been using this board here, which is a STM32R152 board. It's got the LCD driver built into it. So I've been having a play with that and having a play with this LCD driver. So I've kind of got that part of it worked out. I know how to code that, either using third libraries or actually my own code, which I did. But for this project, I don't need a 32-ARM-bit processor, Cortex processor. I'm running a clock here. It doesn't need to be anything more than an 8-bit processor. So there is a ST8 processor with an LCD driver built into it. This chip has a 4x28 pin driver, or 4x28 segment driver, and the ST8 has a 4x28 segment driver. A 4x28 segment driver, so it should do, although there's a few things I need to check. Layout-wise, the strip connector for the LCD strip needs to, I think, probably be in the same place. I've made up a breakout board for that, or say I've made it up, I've sent it off to be made. Can't be bothered messing around with chemicals to do it here. So I've just sent it off to be done. So it's got a 0.9 pitch connector over there, and it's just a breakout into a normal breadboard pitch, the 2.54 pitch pins coming out. And that just means that I can then connect that onto here. I can restick that back on and plug it into the breadboard and then develop, particularly around mapping that out, because that's something I still need to do, is to map out all the segments. And I did start doing it with some probes on here, but I was worried about damaging the flexi strip, so I stopped doing that. And I thought, let me just do it properly. And besides, I'm going to need it for prototype development anyway, before I develop a main board. So yes, I was getting back to the space. I was having a look at how much space I have on here, and I was trying to draw out the areas where it interferes with the casing, where I can and can't put components. But it occurred to me, just get that out of the way. It occurred to me that this goes on over here. It clips on. Just get those out of the way. It clips on over here, and I've got all of that space to play with. And this is about a centimeter deep over here. So I could almost put a Raspberry Pi in here. I think it's touch small for a Raspberry Pi, and I don't need a Raspberry Pi. But it does afford me a whole lot of extra space and some other possibilities. This chip is a Wi-Fi module, which I will build into it. So the whole point about this project was to replace the insides of this with something which is a bit more flexible. So one of the frustrations I have with this clock, as amazing as it is, and it works really well, is that I can't set different times for different days. So, for the weekend, for instance, I want him to leave us to sleep for a bit longer before he comes through. So the GroClock is what it does. It tells you, it helps the child understand when they can come through or when they can get out of bed. So on the weekends, that's later. During the week, it's obviously much earlier in the morning. And it means if I've forgotten on a Friday night, I have actually got up at 2 o'clock in the morning, remembering that I hadn't reset his clock back to 7:30 in the morning for the early morning limit for the weekend. Joys of having a 4-year-old. So I wanted to be able to do that, and I was thinking initially about putting in a Bluetooth module, but then thinking about that, if I'm going to do a Bluetooth module, I'm then going to develop a small app for either the Android or iPhone. I have an iPhone, but I don't have a Mac, and so developing an app around that it's just a pain. So I thought I'd go for a Wi-Fi module. This Wi-Fi module has got a full stack in it. It's got obviously a TCP/IP. It's got the TCP/IP stack in it. It's got a web server, a web client. I can load in some micro Python, which I'm assuming, I haven't tried this before, but I'm assuming I would use that to create a small web page on here so that I can access it. And then it's just normal TTL data connection, USART data connection onto the processor to talk through. So it allows me to then connect to the clock via the home internal network anyway, and adjust the settings and have a play with that. So one of the amusing things I find about this is that the processor I'm looking to replace this with is an 8-bit processor. As I said, I don't need more than that. It's a clock and it's got a built-in real-time clock in it as well, and it's got an LCD driver in it. I really don't need more than that. So it's 8-bit is I think the one I'm going to go for. That is a 32-bit ARM Cortex. And so I just kind of find it quite funny that the module that I'm using to allow it to communicate to the world is just so much more powerful than the actual clock I need. I mean, I don't know. I might be able to even run, actually not for the LCD. I was about to say I could probably run the entire clock function inside there through MicroPython, but I still need an LCD driver. So as I say, there's a bit of an update. I'll head over to the PC in a moment and we'll just go with some of the data sheets for both that module and the ST processor. I'm going to have to think about the power supply design. I'm not too worried about it because it is this is not battery operated. So efficiency side of things and power consumption, I'm not really that worried about. I only need one power supply, which is nice. And yeah, we'll see where we go with that. So yep, got to map that out, get the breakout boards when that arrives, get that attached, and have a. So what I'll do as a video after this is I'll have a play with that. I can see if I can find a connector. Otherwise, I'll just solder onto here. But I want to have a play with that and see what its capabilities are and see whether it'll work for this project. So there we are. That's where we are on that, and let's head over to the PC and just have a look at some of the data sheets. So the first thing I'm going to do is have a look at the ST8 Cube MX application. I just find this is quite a nice way to have a look to see what processor to choose. Yeah, so I've had a bit of a look around, and I think the one that I think will work is the STM8L152R8T. It's got enough memory on it. It's got more than enough memory on it and programming space. I won't need any more than what this has got. But it has the LCD driver built into it, which is the main selector for this chip. It's got a real-time clock built into it with alarm and calendars. So I don't need any external components from that point of view. In fact, everything I need other than the Wi-Fi module is in this processor. I think this will probably do the trick. So I've just been having a bit of a play around here to see whether everything fits in. I've got a UART connection over here so that I can just have some serial communication coming out that's mainly for debugging. And I've got, so I've opened up the SPIs and the IC2s. I'm not quite sure which, if any of those I'll use, but I wanted to put them in there to make sure that I still had enough LCD segments, which is kind of the main thing, because obviously these are shared between different alternative functions. So I wanted to make sure I had enough LCD segments and enough for GPIO buttons for the GroClock and some communications and some debugging to come out and so forth, and a bit of expansion. I've got a few more empty ports here. So I think this chip's going to work really well. It's STM8L152R8T. It looks to be the part. I've looked through a couple of other chips and I think this will do the best. As I said, I'm sticking to an 8-bit processor. I don't need anything more than an 8-bit processor for this. After all, it's just a clock. So the other thing is the Wi-Fi module that I'm going to use. I bought one just to have a play with, and I think this is, this is the kind of thing I'm looking for. Whether I'll actually use this one or not remains to be seen. But it's got just about everything in it I need. TCP/IP stacks built in. It's got a RESTful API to get and post web content. a web server supporting dynamic web pages, 8 simultaneous connections. I'm certainly not going to need more than 8. I mean, I need 1 connection at a time. UART command set. It does somewhere over here talks about MicroPython, but you can upload MicroPython in here, and I'm assuming that's what the web server web page is going to be for. You're going to have to load HTML and Python to do stuff. I mean, it's quite powerful. It's got a lot of GPIOs on it. As I mentioned earlier, there's actually an ARM Cortex chip on here. So yeah, I think I'm going to have a play with this, and we'll see what we'll see how well this works. There's a couple of different modules. This is a slightly cheaper one. There is this I think was £11 for this module. There's a £19 and a £22 module that have different functionalities. And I think the bigger difference in them is really the software, the integrated software that they've got built into them, and what the web servers can do. But this will be fine to have a play with. So yep, I'll give that a go. I think I'm happy that I'm going to choose this chip. So what I'll probably do is start laying out a board with this chip on it and the power supply. I'm going to have to do another whole, well, I'll see if I'll do another whole video on the power supply selection. It's something that I always struggle with a little bit. There's so many variants of DC to DC converters. And yeah, it's just a huge world. I sometimes find it difficult to know which DC to DC converter I should be using. But like I said earlier, I'm not too worried about it in this project because it's not going to be battery operated. The efficiency is not that important. I want stability is really what I want. I could probably just do a low dropout regulator on here, but I think I'll do the DC to DC converter anyway, just because. There's a lot of online designers, and you can just give it the specs and it gives you the whole design, which I think is probably the route I'll go for the power supply design. Right, so there we go. That's a quick update, and we'll see where we end up with that. I'll do a second update when I'm a bit more firmed up on exactly what I'll be using, and when I start laying things out and deciding things. I'll put a web page up on my website detailing the specs and everything that I'm doing on here as well. So it'll be YouTube video updates and probably a bit more detail on the website. So follow that, and it'll be linked in down below. But in the meantime, please click like if you like the video, and definitely subscribe so you can get the updates and follow me on all my adventures. That would be much appreciated. Speak to you soon. Bye-bye.